Hey YouTube, what's up, Link? Welcome back to another episode of Coding Session. So I got my Leetcode weekly digest email this week, and when I opened it up, I was quite disappointed because my problem of the week was, or is, the Roman to integer problem. Now, like I said in the reverse binary tree episode, I don't recall what episode that was. It was quite a few episodes back. I'm not familiar with going into full on technical whiteboard interviews. And a lot of the solutions you're going to see for this particular problem are very long solutions, and uh, there's many ways to go about doing this problem, but this is a very long and can be confusing problem. While the difficulty is that easy, check out the like and dislike ratio. It's obviously a lot of people don't like it versus people who actually enjoy this problem. So pretty much the problem is convert a Roman numeral number, which is taken in by string s, and convert it to an integer. So how do we go about doing that? So I've been messing with dictionaries recently, especially in the Amlite project I am involved in at my university. Um, I believe I haven't shown that part, but we have updated the prototype algorithm for the depth first search exact path algorithm to where if it doesn't find any path, we're going to collect all the paths in a dictionary and analyze them later to see what's the closest one. So I've been messing around with dictionaries a bit, and I've been also wanting, I've been learning JavaScript as well recently because I want to go ahead and uh, just be able to perform basic tasks with JavaScript. Um, and you can also think of a dictionary kind of like a JSON object as well, which is a JavaScript object notation. Um, Obviously, that's different from just plain old dictionary data structure, but very similar in some aspects. So a dictionary, and we have the C sharp collections of it here, is pretty much a data structure that holds a key, and with each key in the dictionary is associated with some value. And the key and the value can be uh, different data types or the same. It's really up to you of what you're using the dictionary for. So I had an idea to maybe go about taking advantage of the dictionary data structure and actually solve this problem. Excuse me. And let's see what we can do. So we're gonna make a dictionary. We're in C sharp today, not Java. We're switching things up a bit. Private static dictionary, and of course, a string is a collection of characters. Um, but even for this dictionary, all we're going to be storing, especially since it's a static, is just each symbol and its value. So the symbol is going to be its key, and the value of each key is going to be the actual value of it. So car int map is equal to new dictionary car int. And the reason why I'm using dictionary is this is this this problem or this solution that I am writing is going to be a little bit shorter than a lot of the solutions you're going to see, particularly for this problem. So I, which is 1, um, v, which is equal to 5, x, which is equal to 10. That's L's next. L is equal to 50. I've never seen actual C, D's, and M's. I've only seen all the way up to L. Uh, so C is equal to 100. This video is going to be long because writing the actual dictionary is what's going to take up the most time. Sorry, I don't know. I kind of like daydreamed there. D, which is equal to 500, and then finally we have M, which is equal to 1,000. And then we'll end our definition of the static dictionary right there for each of the Roman numerals. And actually, I don't know, I mean, I just realized that I'm writing a private static variable, or object, I should say, inside an instance, or a method. So let's write that outside, move that over there, and actually implement the Roman 2 int method or function. So I'm gonna want 3 variables, which is current is equal to 0, our current is equal to previous, is equal to number, is equal to 0. And what we're going to do is we're going to use an enhanced for loop, which is a for each, and iterate through every single character in the string. Remember, a string is a collection of characters. So for each char c in the input parameter, which is string s, we're going to want to set the current to map of C, which is going to be the key, and then it's going to get its value and store it into current. Remember, a character holds a single character's ASCII value, which is why we can put it into a 32-bit int variable. And we're going to do if the current is greater than the previous. We're going to write the code. I'm actually going to explain this in a semi-visual way. Number is minus equals to 2 times the previous. Of course, when we're starting out, it's not going to be the case. The first number, first Roman numeral. And all the time, we're going to want to do number plus equals current. Still in the for each loop, of course, we're iterating through each one. We want to update the actual number, and then previous is equal to current. And then outside, we want to just return numbers. So how does this work? Well, if you don't know how Roman numerals work, I don't know. I mean, I would imagine everyone does. I'm going to use this space down here to kind of visually go through this. So we're going to use the example of 5 and 11. So here, in order for this to be 5, you see 5, which is V, and you see 1. Any number, a Roman numeral that has a value less than the one after it, you're going to subtract. So 5 minus 1 is equal to 4. And of course, that's the opposite for situations where the Roman numeral is greater than the one after it. So that is 10 plus 1 is equal to 11. So how this is going to work, we'll go back to our 5, for example. For the first iteration, or for each loop, if 1, which is the current now, is greater than the previous, of course this is going to be the case for the first Roman numeral. This is true, so number is going to be minus equals 2 times the previous. Now the previous is 0, so that's just going to be 0. Number plus equals the current, so currently we're at 1. And the previous is now 1. So now we go and iterate again, and if 5 is greater than 1, it is. So it's going to do number minus equals 2 times the previous. So number is going to equal to, well, it's getting really confusing. It's going to be equal to 1 minus 2, which is equal to negative 1. And of course, we're always going to want to update number with plus equals current. And if we do negative 1 plus 5 is equal to 4. And that ends up being 4. So that works perfectly fine. And now I'll handle it for every single Roman numeral in the string. just that kind of basic algorithm. So for 10, if 10 is greater than the previous, which it is, that's just going to be 0 for the first one. And then we're going to add 10, so number is now equal to 10. And the previous is equal to 10. So then we go through the next iteration, and now we get 1 for I, which is 1. And if 1 is greater than the previous, which is 10, that is incorrect. That's not true. The condition is false. If the code in the if statement block does not execute, and thus number is going to equal 10 plus 1, which is going to be equal to 11. So that's how that algorithm works, and that's going to go and iterate through each character in the input parameter string s and work for every single Roman numeral in the string. So let's see if this works. Compile error. Oh. Yeah, I don't know why I thought I can do this, because we're only declaring just int just int current. We can't just do equal if it's not declared. So I'll do previous. I'll just do this. Better safe than sorry. Equal to 0. Equal to 0. There we go. Let's run our code again. There we go. So I believe within this time complexity, especially the for each, this might be O of n. So that works for the first test case. Let us test all the test cases. And there we go. Runtime is 84 ms, and it's faster than 87.83 of the C# submission. So that's pretty decent. So there's going to be a lot of solutions, of course, in many languages. Of course, since this is using a dictionary, you definitely can solve this in Python if you really want to, very easily. But this, using the dictionary data structure, which a dictionary holds a key and a value, holds a collection of objects based with a key and a value, and the key allows you to identify what value or object it is linked to it. So it consists of a key and a value, and the key is used to identify the value linked to that key. Just like a dictionary, like we have apples as a key, oranges as a key, and its value for apples and oranges is the definition of apples and oranges. That's just like a plain, bland, brief example of that in plain words. So yeah, the dictionary data structure comes it's pretty useful in a problem like this. But if you go into the discussion for this problem, there is going to be a lot of solutions you see where there's many ways to do this problem. A lot of solutions are very long. But some solutions, like this one that use a dictionary, tend to be short, simple, sweet, because the dictionary is very optimal to use for this type of problem. So we're going on 14 minutes and 23 seconds. Half of that was just building the static dictionary, as we see here, and also explaining how Roman numerals work and how they work with this algorithm we have here to store the current one, and current equal to previous, then do number minus equals 2 times the previous, which will go ahead and handle if the Roman numeral before the next one is smaller. In this case, of course, you subtract it. And if not, of course, we're always going to add to the current, and then set the previous to current so we can compare it for the next one. And of course, this handles if the Roman numeral, the Roman numeral in the first place is greater value than the one right next to it, the next one, then obviously don't subtract, just add to number. So, thank you guys for watching. This was the Roman to integer problem on Leetcode. And based off the like and dislike ratio, it's not pretty, because there's many ways of doing this problem, and as far as I can tell, dictionary is just one of those data structures that's very optimal for this problem. So thank you guys for watching. Again, leave a comment down below if you want me to further explain anything or clear up an explanation on anything discussed with this problem or Roman numerals in general, and I will do my best to assist you. Have a nice day. Thank you guys for watching.